Hi, my name is Jiu, and I'm a high school student, and in this lecture I will be discussing how some mushrooms or mycelium can thrive in radioactive environments such as the now abandoned nuclear power plant in Chernobyl, Ukraine. So a little bit of backstory on Chernobyl. It's known as the worst nuclear accident in history, and in 1986 one of Ukraine's nuclear facilities blew up as a consequence of a surge of power. What followed was an explosion and massive amounts of radioactive material released around the area, or up to 30% of Chernobyl's 190 metric tons of uranium. In the present day, almost 4 decades later, a fascinating phenomenon is taking place in the exclusion zone. Nelly Zhdanova, a mycologist and ecologist, states, scientists had discovered at least 200 species and genera of fungi thriving off radiation at the disaster site. It was observed that these mycelium were growing on the wall of their nuclear reactor, which was still very well covered in strong gamma ionizing radiation. So mushrooms or mycelium living in a radioactive environment are considered to be extremophilic, and to be even more specific, radiotrophic. And radiotrophic organisms are types of extremophiles that specifically survive and thrive in a radioactive environment or ecosystem. And in Chernobyl, the reactor pool water is highly radioactive as it circulates through the nuclear reactor core. This type of moist and shady environment is perfect for fungi, which could suggest that radio-resistant organisms, such as mycelium, will deliberately access these areas, even though they have high radiation fluxes. And so how do they do it? So melanin has a great shielding effect against radiation. It can be seen when human skin is exposed to UV radiation, such as sunlight. Melanin will build up in the skin to protect it from getting damaged, which is why skin gets tanned after a prolonged exposure time in the sun. Instead, the melanin granules of mycelium are tightly packed to the cell wall to act as the mycelium's own eumelanin and create strong chemical bonds to carbohydrates, which strengthen the structure of the cell. In an experiment done by Zhdanova, all the results were that 66.7% of fungi showed positive stimulation of growth towards the radiation source, proving that melanated mycelium species will use their high melanin content in the search of radioactive surfaces. The attraction to those surfaces is called radiotropism, and it's the process by which radiotrophic organisms, such as certain types of mycelium, use to turn radiation into a source of energy called radiosynthesis. And so this basically means that microfungus are able to grow into and decompose the hard particles of radiation. In some cases, researchers have even discovered that mycelium fungi could protect their DNA and use ionizing radiation as energy for the DNA repair. In the most present energy crisis, governments are turning to the use of nuclear energy. Though it proves to be an effective energy source, the dangers surrounding it are of great concern. Though the mycelium in Chernobyl can only consume very small amounts of radioactive waste at a time, I can't wait to see if more research will dive deeper into the possible solutions for nuclear waste concerning fungi.